Hello guys, my name is Geeta Soumit from College VVIT CSEC section. Today I am going to say about my physics seminar and the topic is interaction of radiation with matter. This is from the chapter lasers and holography. So first of all, before going into this topic, we need some introduction, we need some points about laser. So the abbreviation of laser is light amplification by stimulated emission of radiation. So here we are going to learn about what are the different types of lasers, what are the different applications of lasers, and what are the different processes that which are responsible for production of laser. So what are the characteristics of laser? So as we know that in the abbreviation itself, stimulated emission of radiation. So we will briefly discuss about what is meant by stimulated emission of radiation, how it is occurred, and what are the different possible ways for stimulated emission of radiation, and different topics we will cover in this seminar. So let us going into the topic. Our topic is interaction of radiation with matter. So according to Albert Einstein, who is a great physicist, there are three types of interactions of external energy with internal atomic energy states. So they are mainly stimulated absorption, spontaneous emission, and stimulated emission. So the stimulated absorption, these three interactions were mainly postulated by Albert Einstein. So we all know that the stimulated absorption and stimulated emission is given by the great physicist Albert Einstein, and the spontaneous emission was given by the Niels Bohr. So let us discuss about all these interactions briefly. So firstly, stimulated absorption. So what are the different ways to for production of a stimulated absorption? As we all know that the atoms are usually present at ground state. So we are studying from lower class itself that atoms are very stable at the ground state. So they are usually like to be present at the ground state. So let us consider two atomic states, atomic orbits, two atomic states, which is E1 being the ground state and E2 being the excited state or higher state. So as we know that atoms usually reside at the ground state, which are stable. So the atom is at E1. Here in the picture you can see that the atom is at E1, which is at the ground state. So the stimulated absorption is given as when a photon of radiation h mu is incident on the atom acquires the energy of the photon h mu and jumps into the higher orbit. Once again, the atom acquires the energy of photon and jumps into the higher orbit. This is known as stimulated absorption. So the energy h mu is nothing but the difference between the two energy states. So this is about the stimulated absorption. The second interaction of radiation is nothing but spontaneous emission. This was given by the Niels Bohr. That is, after the atom is excited into higher energy state, the lifetime of the atom will be reduced. So first of all, here we need to know about what is meant by the lifetime. The lifetime is nothing but the time spent by the atom at its higher energy level or excited state. So how much time does the atom spends its time at the higher energy level is nothing but its lifetime. For a hydrogen atom, usually its lifetime is about very low, that is nothing but 10 power minus 8 seconds. So according to spontaneous emission, the principle is after the lifetime of an atom, the atom usually comes down spontaneously to the ground state from the higher energy state. So in this process, the atom emits energy of h mu. So it is also known as, it also emits a photon of having energy h mu, and this h mu is equal to the difference between the energy states. The difference between the energy states is nothing but E2 minus E1. Here in the spontaneous emission, we can see that the atom before the photon emission, the atom is at higher energy state. As we considered in stimulated absorption, the atom is at higher energy state. After completing its lifetime, the atom spontaneously decays to the ground state by emitting a photon of radiation h mu. This photon of radiation h mu will be equal to the E2 minus E1, that is nothing but difference between the energy states. The note point is that the photon emitted is incoherent photon. The photon is known as incoherent photon. So this is incoherent photon. This is about spontaneous emission. The third emission, which is the most important emission, and which is the emission which is responsible for production of laser, is nothing but stimulated emission. So let us assume the atom is in its metastable state. So let us know about what is meant by a metastable state. If the atom is present more than its lifetime, then it's said to be in metastable state. That is nothing but, usually for a hydrogen atom, the metastable state is nothing but 10 to the power of minus 3 seconds. So here we can understand that the atom will be present in the higher orbit after its lifetime. After completion of its lifetime, the atom will also be present at the higher orbit, which is termed as metastable state. So these atoms which are present at the metastable state comes down to the ground state with the external agent. The external agent is nothing but the photon which is emitted at the spontaneous emission. So as we know that here the spontaneous emission, the photon is emitted. So this photon is responsible for the other atoms which are in metastable state for coming into the ground state. The photon which is emitted in spontaneous emission influences the atoms or electrons which are present in the excited state. So due to the influence of h mu, the other atom which is present in metastable state at higher orbit comes down to the ground state. As it is during this process, when it is coming down to the ground state, the atom also releases a photon of energy h mu. So after the stimulated emission, the output will be 2 photons of having energy h mu, and this h mu will be equal to the difference between the energy states, that is nothing but E2 minus E1. So this is about the stimulated absorption, the laser which is mainly produced due to this stimulated emission. So here we can see all the combined diagram of stimulated absorption, spontaneous emission, and also stimulated emission. So here the atom, let us consider two states E1 and E2. The atom is usually present at E1. Before emission, having when we send a photon of having energy h mu to the atom goes to the higher orbit. So after completion of its lifetime, the atom spontaneously decays to the ground state, releasing a photon of h mu, and this photon of h mu is responsible for the atoms which are present in the metastable state. The atoms which are present in the metastable state, the photon which is released in the spontaneous emission is responsible or influences the atoms present in the metastable state. So due to the influence, the atoms present in the metastable state comes down to the ground state by releasing a photon of energy h mu, and this h mu will be equal to E2 minus E1, difference between the energy states. So after emission, we are getting a for one photon, we are getting, for one atom we are getting 2 photons. So that is why the laser is having high intensity. Here the energy is high. As energy is high, intensity will be also high. So the reason behind laser having the high intensity or high energy is nothing but releasing of 2 photons. So as for one atom, there are 2 photons are coming. So there are many atoms present in the material. So there will be a huge photons emitting from the material, that is termed as laser, and it has high energy and high intensity. So the final point we need to consider is that the 2 photons which are emitted after the stimulated emission, have same propagation, same phase, and same energy. That is nothing but we are saying it as coherent. The photons which are emitted in a stimulated emission are coherent. So this is the main reason of production of laser. So these are various interaction energies given by the Albert Einstein and Niels Bohr, that is stimulated absorption, spontaneous emission, stimulated emission. So laser having high monochromaticity due to these processes, and is also having high coherent in nature, and high directionality, high intensity, All the characteristics can be proved from this interaction of radiation with matter. So this is about my physics seminar. So thank you, one and all.